Okay, now we'll see the vector form of the Coulomb's law. So this is just a normal form. Now we'll see how to write the vector form of the Coulomb's law. So we are doing the vector form. Vector form of the Coulomb's law. To express the Coulomb's law in vector form, we have to take the help of the coordinate system. A frame of reference is needed. So here's I have a reference frame, x-axis, y. These two are enough. Okay. Now in this frame, I have two particles, Q1 and Q2. Okay, let them be both as positive. So distance of Q1 from the origin. So what is the need of writing? What is the use of using a coordinate system? It will help you give the distances from the origin. Okay, we are measuring everything with respect to this particular origin. With respect to this origin, we'll measure their distances. Okay, so distance of Q1 from the origin will be R1. It's a vector, so it's the tail, and here's the head of this vector. Okay, similarly, the distance of Q2 from the origin, Q2 bar, this is the vector. Now if I want to find out the force on the particle 1, the charge 1 due to 2, the direction of the force will be in this direction. Okay, while finding the force on Q2 due to Q1, I'll take a vector between Q1 and Q2 as this, the vector who is having direction in this direction. Okay, so this will give me force who is having this direction, that will be force on 1. This is the particle who is experiencing 1 on due to 2. So it's a vector in this way. So that's why while finding the force on 1 due to 2, I'll take this vector. So what is the value? What is the value of this vector? If you have, suppose this is the origin, if you have a vector like R1 like this, R2 like this, and they are having some distance. This distance, if this vector, I am calling it as capital R. The value of capital R can be found out. You see, we are going from here to there, and again from there to here. So we are taking 2 steps to reach this point, but R1 is the single step with which we can reach this point. It means R1 is equals to R2 plus R. So what is the value of R from here? R is equals to R2 minus R1. So similar method I'll be using here to find out the value for this vector. So I am calling it as R12 is equals to R12 is equals to R2 R1 minus R2. Okay. Similarly, while finding the force on 2 due to the first particle, due to Q1, the direction of force will be this way. F on 2 due to 1 will be in this way. While writing the expression for this force, we have to use a vector whose direction is along this way, from Q1 to Q2, not from Q2 to Q1. Q2 to Q1, this vector we will be using for writing this expression. Now to write the expression of the force on 2 due to 1, we will be using this vector. So the value of this vector with this formula, it is 2, 1, 2 R2 minus R1. Getting my point? Now let's write down the expression for the force on first particle due to 2 in vector form. This represents due to which particle the force is acting. On which particle the force is acting? The force is acting the first particle, the Q1. So this is equals to constant K, the magnitudes Q1, Q2. So it's not a sign sensitive equation. Sign sensitive equation means whatever the signs are there, the signs of Q1 and Q2 we have to take into account, but it is not a sign sensitive expression. That's why you can neglect the amount, the sign. Okay, you just have to worry about the magnitude divided by the distance between these two particles. So while finding this expression for this force, we'll be using this vector. This vector is giving the distance between Q2 to Q1. Okay, this expression, what is that? R1 minus R2 whole square. So this is not in vector form. Equation will be in vector form. You have to write the unit vector along the line joining Q to Q1. What is the unit vector? Okay, so here the unit vector for this vector is, how to write unit vector? This will be the unit vector, Q1 bar minus Q2 bar. If I write a cap on it, it represents, it's a unit vector along that particular vector. So that value of the vector, what is that vector? This is the vector. Divide by its magnitude will give you the unit vector along that direction. It is something like this. If you want to write the, suppose I have a vector A, and if I ask you to find out, to get the unit vector of this vector, how will you find? We'll take the A cap will be equal to, A cap is the unit vector along this direction, will be the vector divided by its magnitude will give you the unit vector. Similarly, we now, this is not yet a vector. Okay, to make it as a vector, the force as a vector, we have to multiply this thing with a unit vector along the direction of the force acting. So this is the direction of the force acting. So here this vector's a small unit vector is this. So we will multiply this unit vector. Now this force is in a vector form. The force magnitude is this and the direction is along this way. Are you getting my point? Then only you can call it as a vector. Now similarly, we can represent the force on 2, the second charge, due to the first charge. How will you represent that? The force on 2 due to 1. Due to 1. Okay. It is equals to K that is constant K Q1 Q2 by, now here which vector, which distance we will use? We will use this one because the direction of the force is in that direction. So because we are writing it in a vector form, we have to take this vector, not this vector. So the upper vector is giving the direction, it is having the direction where the force is acting. Force is acting that way, and this distance vector is also in that way. That's why you have to take this vector. That is what? R2 minus R1. So this is not in vector form. How to write this expression in vector form? We have to multiply with unit vector. Okay, the unit vector of this vector. How to find out the unit vector of this vector? You have to what is this? R2 minus R1, its cap, the unit vector will be represented with cap on it, will be vector divided by its magnitude. How much it is? Divided by its magnitude will give you unit vector along the direction of the vector. Now if we multiply this expression with this unit vector, this force will become a vector. Whole cap. Now there's one more thing that we can do. We can replace this thing, this unit vector with this. If I replace this unit vector with this, what I'll get? I'll get K Q1 Q2 divided by mod R2 minus R1. Already one R2 minus 1 square will be there. Already R2 minus R1 square is there. One more R2 minus R1 is coming, so it will become Q, and here what will come? This vector R2 minus R1. So you might say that, sir, this is not the right equation because the force, the relation between force and the distance between the particles will follow the inverse square law, but this equation is not following the inverse square law. Here you are getting Q, but the same quantity is upstairs also, so you can cancel out. You will be having just R square. So that's why it doesn't matter. Only just to write it in a vector form, we have written like this. Okay, this is what? F force on 2 due to 1. Similarly, you can write this expression also in this form. It will be force on 1 due to 2 will be equal to K Q1 Q2 by R1 minus R2 whole cube. Now the vector R1 minus R2. Okay, this is also in vector form. So this is called the vector form of Coulomb's law. Okay, so while solving the problems, we won't be using this much complicated expression. We'll be using simple, like if the force is along x direction, we'll be writing the expression for force, whatever is the magnitude. And if the direction of force is along x direction, we'll be writing a unit vector along the x direction. What it is? I cap. We'll be writing simply whatever the magnitude we will get while solving the problem, after solving the problem, and we'll multiply it with I cap. Now the force will become a vector. Without, only if you write some magnitude, it will be just F. But if you know that the force, the direction of the force is along x direction, if the force is acting in that way, you have to take I cap. So that's how, if you write magnitude with I cap, whatever force you have you got, that will become a vector. Okay, if the direction of the force is in this direction towards this way, then you have to write the force with minus I. With minus I. If you are writing minus I, then it means the direction of the force is in negative x direction. Are you getting my point? If the direction of the force is upward direction along the y direction, then you have to write force, whatever magnitude you got, along the y direction. If the force is acting along the y direction, then you have to write j cap. Okay, for example, you have one particle here, a positive charge, other positive charge is here. So this is charge 1, this is charge 2. And if I told you, tell me the direction of the force on 1 due to 2. So due to 2, the force on 1 will be upward. Okay, so the direction will be j cap. The magnitude will be what? The force will be like, the magnitude will be k q1 q2 by, if the distance between them is r square. Okay, now you can write vector. Okay, so this is how we will be using while solving the problem, not these kind of complex things. Okay, but in the exam, in the IP exam, you will be getting write the vector form of the Coulomb's law. So this is how you have to do it. Okay, but while solving the problems, we will be doing this method, just where the direction with the help of the diagram you will get the direction, and if it is towards the y-axis you just have to write j cap. If it is towards the x-axis you have to write just I cap. If it is towards the z-axis you have to write k cap. If negative axes are there, the force is along the negative axis, you just have to write minus I, minus j and minus k. Okay, this was all about vector form of Coulomb's law. Now let's solve few problems based on Coulomb's law. Okay, now the question is, we have three particles q1, q2 and q3, having distance between q1 and q2 as 1 r1, the distance from here to there, and the distance from q2 to q3 is r2. The charge on q1 is positive, the charge on q2 is negative, and the charge on q3 is again positive. This is the situation. Now what we have to do, we have to find out the forces on q1, q2, q3. Okay, now let's see how to do this question. Now if your force on q2 will be due to both q2, the force on q1 will be due to both q2 and q3. Now first let's see the force due to q2 on q1. You see, this is a positive and here this is a negative. So because they are having different polarities, the force, whatever is the force on q1, it will be towards the q2 because they have different polarities. How much will be the force? Force will be force on q1. We are finding force on q1 due to q2, means you have to write 2. This 2 represents due to which particle you are doing. Okay, so this force will be k q1 q2 divided by the distance between them square, that is r1 square. Now this force is along this direction. You see x, y, z. If the force is along x axis, the unit vector will be I cap. If the force is along y axis, the unit vector will be j cap. If the force is along z axis, the unit vector will be K cap. Now you see the force is along x-axis. Okay, so to make it as a vector, what we have to do? We have to multiply it with I cap. Okay, this is the one force that is due to Q2 on Q1. Now let's find out the force on Q1 due to Q3. Now you see, because they are having same polarity, same sign, positive, positive. So because of this Q3, the Q2, the force on Q1, not Q3, the force on Q1 will be this way, away from the line joining the Q1 and Q1 and Q3. So this force will be force on Q1 due to Q3. This is due to Q3. So it's a vector. Now what is the magnitude? Magnitude is Q1, Q2. Oh sorry, K will be also there. Divided by the distance between them. What is the distance from Q1 to Q2? The distance from Q1 to Q2 is R1 plus R2. So R1 plus R2 whole square. Now this is just a magnitude. What about the direction? The direction, you see, this is the x-axis, but the force is towards this way. This is the negative x-axis. If the force is acting this way, you have to write minus I. If the force is in this direction downward, you have to write minus J cap. Now the force is in this direction, that's why it will get minus I cap. Okay, so now the net force on Q1 is equals to the force Q1, the force due to Q2 plus the force due to Q3. Now if you add them, this force, how much it is? K, Q1, Q2 divided by Q1 whole square I cap minus this force K, Q1, wait. Here it should be Q3 because we are doing the force between Q1 and Q3. That's why it will be Q1 and Q3. And Q3 divided by R1 plus R2 whole square I cap. So here it was having I cap, but that minus I cap was there. I've taken minus this way, that's why it became like this. Now I can take common Q. So similarly, we can do the force on Q2 and Q3. Now we will find out the force on Q2. So to find out the force on Q2, now first we'll find out the force due to Q1. So Q1 is a positive and Q2 is a negative, so there will be attraction. So the Q2 will move towards the Q1. The direction of the force will be this, and that force will be force on Q2 due to Q1. So this force will be, I am writing this force here, Q21 will be equal to K Q1 Q2 divided by R square. The direction of the force minus I cap. Now force on Q2 due to Q3, they are having different polarities, that's why again the Q2 will move towards the Q3. This is the force direction. The force on Q2 due to what? Due to Q3. This force will be F23 will be K Q2 Q3. The distance between them R2 square. The direction of the force along the x-axis, so it will be I cap. So the net force on Q2 will be equal to force F21 plus F23. It will be, if I add them up, what is the common thing? The common is KQ2 by, just not anything, just KQ2. If I take it outside, what will be there? Q1 will be there from the first term, divided by R1 square and a minus I cap, plus from here I have taken KQ2 outside. What will be there? Q3 divided by R2 square with the I cap. So this is the force on Q2 due to Q1 and Q3. Similarly, we can find the force on Q3. So first, the force on Q3 due to Q2 will be, because they are having different polarities, this Q3 will move towards Q2. So the direction of the force will be here. The force is force on Q3 we are finding. Due to what? Due to Q2. That's why 2 will come. So this force is 3-2 will be K Q2 Q3 divided by, what is the distance between them? R2 square. Okay, now the direction of the force. The direction of the force is negative x-axis. It means minus I cap. Okay, now the force on Q3 due to Q1, because they are having same polarity, the Q3 will experience force away from the Q1. So direction of the force will be this. That is force on 3 due to what? Due to 1. So this will be F31 K Q1 Q2 divided by, not Q1 Q3 divided by the distance between Q3 and Q1, that is R1 plus R2 whole square. The direction is along the positive x-axis, that's why it will be I cap. Now the net force on Q3 will be F32 plus F31. So from these two equations, what we can take common? KQ3 is common. KQ3, if I take common, I have taken KQ3 outside, what will be there? Q2 divided by R2 whole square minus I cap plus KQ3 is out, what remains? Q1 divided by R1 plus R2 whole square with a I cap. So this is how you can find. So this is the force on Q3 due to Q1 and Q2. Now let's solve one more problem. Now the next question is, we have two charges plus 10 microcoulomb and minus 20 microcoulombs are placed at a separation of 2 centimeters. Then what we have to do? We have to find out the electric force between them. So first thing that you do is read the question and try to make the picture of the situation what you have. Okay, once you write the question in a diagrammatic manner, it will be so much helpful for finding the answer. Okay, the question is, we have two charges. One charge particle is having charge plus 10 microcoulomb on it. The other charge particle is having minus 20 microcoulomb. The separation between them is 2 centimeter. Then we have to find out the force between them. Okay. Now, to find out the force between charged particles, we will be using the expression. Which expression? The Coulomb's law expression. Expression is K, F is equals to K, Q1 Q2 by R square. Okay. So the Q1 is here 10 microcoulomb. So microcoulomb means, what is the value of mu? Mu is equal to 10 power minus 6. We have to put everything in SI units. So this order of the magnitude we have to remove, and it will be 10 into 10 power minus 6 coulombs. Now Q2 will be minus 2 microcoulomb. So it will be minus 20 into 10 power minus 6. So forget about this minus sign. This minus sign will just tell you the direction of the force. But if we neglect minus here, this is not a big deal. Finally, we knew that the direction of the force is going to be, if we are finding the force on this particle due to this one, the direction of the force will be this way. If we are finding the force on this particle due to this, then it will be towards this. So these arrows will give you whether the magnitude will get minus sign with it or not. So no need to worry about this charge. So that's why I said that the Coulomb's law is not sign sensitive. Okay. Now substitute the values, and we know that the K value is 9 into 10 power 9 Newton meter square per Coulomb square. Now substitute all the things. So F is equals to K value 9 into 10 power 9, Q1 value 10 into 10 power minus 6 coulombs, Q2 value 20 into 10 power minus 6 coulombs. Now divide by the distance between them. What is the distance between them? Distance between them is 2 centimeter. 2 centimeter is not a SI unit. So centi means what? 10 power minus 2. So it will be 2 into 10 power minus 2 whole square. This is just a magnitude, and if you want to get the direction, suppose you are doing the force on, if I call this as the first particle and this as the second particle, the force on first particle due to 2. The force on first particle due to 2. The force on first particle due to 2. So the direction of the force will be towards this way, towards the x-axis. So this will get I cap. Okay. Now if you are doing for force on 2 due to 1, the force will be newtons. The direction will be the force on 2 due to 1. This will be having this direction, means minus I cap. So this is how you solve it. So that's it for today, and I'll be giving you some worksheet problems. You have to solve them, and if you are unable to solve any of the question, let me know. I'll make the separate video. So thank you so much for watching. Stay tuned.